All right, we're going to take a look at identifying vertical, horizontal, and oblique asymptotes. So let me give you a quick little visual here before we start. These are with regard to rational functions. Okay, and just so you know, this might be, where you'd see a vertical asymptote. You might see that. You also can have more than one vertical asymptote. A horizontal asymptote, obviously. Many times it goes through the origin. Okay, it's y equals 0 is the horizontal asymptote. And then an oblique, that just means a slant asymptote, right? Slant asymptote. And so, it would be basically graphing a line. And so we'll look at that in a minute. But we're going to find out how to identify the vertical, horizontal, and slant asymptotes of a rational function. The first thing that we're going to take a look going to do is the vertical asymptotes, and there are some steps that I like to follow, and these are the 4 steps that we're going to do. We're going to first of all make sure that the numerator and denominator are factored. Then we're going to cancel any factors in common. If we end up canceling something in common, that actually polynomial, or that probably a binomial, is going to, if we set it equal to 0, that'll actually tell us where there's a hole in the graph. We'll look at that in a minute, or actually in a later video. Then we're going to take whatever remains in the denominator and set it equal to 0, and that's where our vertical asymptotes are going to be. We're going to solve for the variable, and that's how we'll know where the vertical asymptotes are. Let's go ahead and take a look at some examples. I'm going to put some right over here, and this first one is just going to be this: x plus 1 over x divided by x minus 3. Okay, I'm going to go ahead and give a couple more so we have them on here. Okay, so let's take a look at these 3 examples. We're going to go through the steps on each one and help identify the vertical asymptotes. First of all, make sure the numerator and denominator are factored. So I look at the numerator and denominator of this one, and I see, yes, they're indeed factored, so I'm good to go. Then we're going to cancel any factors in common. Well, I don't see any factors in common. Now, these right here cannot be canceled because those are not factors. They're add-ins. They're part of a binomial, so they're not factors. And so let's see. The next thing we're going to do is going to take whatever remains, I'm on step 3, in the denominator and set it equal to 0. So I'm going to take whatever remains in the denominator, set it equal to 0, and that is where the vertical asymptote, I'm going to solve for the variable, solve for x, and there it is. I have a vertical asymptote at the equation of the line x equals 3. So I would graph that. I would put that on the coordinate plane with a dashed line. Let's take a look at the second one. It says to make sure the numerator and denominator are factored. Again, check on that. Cancel any factors in common. Excuse me, I'll say check to the top part. The numerator is factored, but the bottom, the denominator, let's look at that. The denominator looks like it can be factored some more. So I'm going to go ahead and factor the denominator. So I'm going to cross that out, and I'll replace it with the factored form. Okay? Now, it says to cancel any factors in common. So I'm going to cancel any factors in common. X plus 1 goes into x plus 1 once. X plus 1 goes into x plus 1 once. This is just like middle school math when you were canceling things above and below to reduce the fraction. So now here's what we have. We have this thing equal to 1 over x minus 1. Now, we're on to step 3. Take whatever remains, okay, that means we're talking about this right here, whatever remains in the denominator, and set it equal to 0. The values of that is the vertical asymptote. We're going to solve, obviously, for the variable. So here we go. X minus 1 equals 0, and x equals 1 is our vertical asymptote. Okay? So x equals 1 is the vertical asymptote. There it is. I'll go ahead and circle this other one. There's that vertical asymptote. All right, this last example here. Make sure the numerator and denominator are factored. Cancel any factors. Okay, they are factored. X squared plus 1 does not factor. Cancel any factors in common. Take whatever remains in the denominator, set it equal to 0, and solve for the variable. So here we go. I have x squared is equal to -1. And I see that I'm going to get, when I take the square root of both sides, I'm going to get plus or minus I, which means there are no vertical asymptotes on this. Okay, so I have none, no vertical asymptotes on that one. All right, let's move on to horizontal asymptotes. So it says if the numerator and denominator are factored, meaning if you've already done calculated your vertical asymptotes, you know, if it's factored, then that's what we were asked to do up there. We need to multiply it back together. Multiply it so there are no parentheses. So we want to have no parentheses. So that's our first step, is go back to the unfactored form. So that's step one. Then next, we're going to look at the leading terms exponent, meaning the degree of the polynomial. We look at the degree of the polynomial for the numerator and denominator, and you're going to, based on those degrees of the numerator and denominator, we're going to put it into one of three categories. So let me give you some examples here. Here's the first one. If it is bottom heavy, now here's what I mean by bottom heavy. Let me give you an example of this. Bottom heavy would look like this. I have, let's say, 3x squared plus 2x plus 1 on top over 3x to the third, meaning the power, right? It doesn't matter the coefficients, and it really doesn't even matter what we have on the rest of the polynomial. Right here, I'm talking about the leading terms degree. There's a 2 over a 3. That means it's bottom heavy. The 3 is larger than 2. If that's the case, then we're going to have y equals 0 as the horizontal asymptote. Okay? Y equals 0 as the horizontal. All right, so the second thing is if the powers are the same. Let me give you an example of that. Here's an example of that one, where we would have maybe 2x plus 5 over x minus 1. And in this case, the power, the degree of the numerator is the first degree, the degree of the denominator is the first degree, and so they're the same powers, right? The leading term is the same. So notice I'm going to highlight here, there's nothing written, but we know it's understood to be a 1. So if that's the case, here's what we do. We pull off the coefficients of those leading terms. Now, what is the coefficient of the bottom one? Well, there was a 1 understood to be there, right? So I pull off the coefficients of the top and the bottom, and I turn that into whatever number it ends up being. And so in this case, y is 2 over 1, which is 2. So there is my horizontal asymptote for that one, if the numerator and denominator's degree are the same. If the numerator and denominator are such that it's top heavy is going to look like this. Top heavy would be like, let's say I had something squared, like that, over just, something to the first power. Let's say it's top heavy. Okay, so this is what I mean. This is to the second power, and this is only to the first power, that x, right? So it's top heavy. Here's what that's going to mean. That's going to mean that there's no horizontal asymptote. No horizontal asymptote if it's top heavy. But if the top heaviness, that's not really a word, but if the top heaviness is such that the top is 1 larger than the bottom, if it's just plus 1 at the top, right? Then we know that there's a slant asymptote. There's a slant asymptote. And what I mean, that's the same thing as oblique. Oblique. Oops. Oblique. Okay, so let's take a look at, okay, let me go back here and make sure we had this right here highlighted. No horizontal asymptote, right? Because it's top heavy on that one. Okay, let's take a look at the oblique. If the numerator is the degree, is 1 greater than the denominator, then we have a slant asymptote. And the slant asymptote really is going to be a line. So let's take a look. I'm going to actually grab this example right here, and I'm going to bring it down here because it was a situation where the numerator was 1 degree larger than the denominator. So here's what we have. We're going to take a look at what the slant asymptote is on this function. All right, so here's what it says. It says divide the numerator by the denominator. And in this situation, I'm going to use synthetic. Right? Use synthetic. So we know that x plus 2 equals 0 is going to be x is negative 2. So I'm going to take the negative 2 and put it on the shelf here. I'm going to grab the coefficients here and put them into synthetic. 1, negative 6, and 1. Here we go. By the way, the quotient is going to be our slant asymptote. So here we go. Bring this down. That's going to be negative 2. There's negative 8. That's going to be a positive 16, and the remainder ends up being, right, that's the remainder, ends up being 17. But we ignore the remainder. We ignore the remainder, and we grab this. We turn it back into the polynomial, the depressed polynomial. If this started out as squared, this is going to be 1x to the first, right? And then we go down from there. So guess what? There's my slant asymptote. This is my slant asymptote. It's actually an equation of a line. That's my slant asymptote. Okay? Hope this was helpful. Thanks for watching.